Welcome to tonight's Alachua Audubon evening program, presented by our Alachua Audubon chapter president, Debbie Segal. Her presentation is Gainesville's treatment wetlands, Sweetwater Wetlands Park, and the planned groundwater recharge wetland. First, a few announcements. Make sure that you're checking our website for our field trip schedule. There are still a few updates that'll be made out there for our November and December trips that still need to be added. But our trips through October are up there, as well as a few of our later seasons events. So make sure that you check out alachuaaudubon.org and look at the field trip section of the website, because they're all listed there, as well as in our recently, I think in the last couple of days, our bi-monthly newsletter, the Crane. So make sure you check those out. This weekend coming up, we have a great one that out to Cones Dyke, led by Scott Robinson. That went to that one last year, and it was it's always a pleasure going out on a field trip with Scott. And Debbie was in great communication with the Park Service, and they mowed the trail, so the trail is clear. And it's going to be a great field trip, so make sure you come out this weekend. And we also just started back up our Wednesday wetland walks. Yesterday we went out, saw about 50 different species of birds, all kinds of good stuff out there. So make sure that you join us Wednesday mornings for our free guided bird walks at 8:30 a.m. at Sweetwater Wetlands Park. And we'll meet there at the front pavilion with the bathrooms and whatnot. So any other announcements I missed, Debbie?
Nope.
All right. Well, thank you so much for joining us, everyone. If you have questions, feel free to put them into the chat. They probably won't be, we'll try to answer them all at the end. But if it'll help you to put it in, type it into the chat so that you don't forget. That's what I would do if you have a question. Or you can just hold it until the end, and Debbie will, address whatever questions you have. So without further ado, I want to, Debbie Segal, she's, just introducing Debbie, she's had a huge impact on many of us as birders, and, with the local Audubon chapter, she's an author, so many things, so many different aspects there. So we're very grateful to have Debbie speaking to us, and especially to learn about this planned groundwater recharge wetland, as well as Sweetwater Wetlands. So without further ado, thank you so much, Debbie, and thank you everyone for joining us.
Well, thank you, Tim. Thank you. So I want to start out first by, for those of you who have participated in a lot of these evening programs, these Audubon evening programs, you know that Emily Schwartz has been the power behind these programs. And Emily has decided to step down from the board after over 2 decades of volunteering with Alachua Audubon. So I just, on behalf of the whole board of Alachua Audubon, I just want to say how grateful, how appreciative we are to Emily for all of her years of service, and how she's brought so many wonderful programs to this evening program session. And so we're just extremely grateful for all that Emily has done for Alachua Audubon. And Zachary Holmes will be taking Emily's place, stepping in to run the programs. And Zach is a graduate student at UF, and he is also past president of Greaves. Greaves is the UF chapter of UF Audubon chapter. So we're really pleased to have Zach, who will be taking over the evening programs. In the most recent newsletter, the Crane newsletter, it should be in your inbox today. Zach has a survey in there, and he's trying to get more information about the programs, finding out what types of programs you would be most interested in. So within the next few days, if you could just take a moment to fill out that survey and send it back to us, that would be great. So with that, I'm going to start off my program. I'm going to talk about the Sweetwater Wetlands Park and the planned groundwater recharge wetland. And just a little bit about my background. I'm a retired environmental scientist, a wetland scientist, and I was on the design team for Sweetwater. So I'm going to give you some information that's kind of behind the scenes that you may not be aware of about Sweetwater, and some of those design criteria will probably be applied to the new groundwater recharge wetland. So to start out with, just a second, can we remove this bar up here? Sorry about that. Move it out of the way. Okay, so to start out, why was Sweetwater built? It was because there was a huge pollution problem in Gainesville, like just about every other municipality. And shown in this slide, if you see the blue squiggly line, that's Sweetwater Branch. It's an urban creek that originates in downtown Gainesville. And historically, that creek flowed to the north part of Paynes Prairie at the top of that peach-colored icon or peach-colored area, and ended there. And so that was the main water, one of the main water sources to Paynes Prairie. Well, in the late 30s and early 40s, the Camp brothers, who owned Paynes Prairie, it was in private ownership, wanted to drain that area so that they could run cattle and have better cattle grazing areas. So they dug a 2-mile ditch from the where Sweetwater Branch ended at Paynes Prairie all the way over to Alachua Sink on the right-hand side. So that effectively conveyed the water to Alachua Sink, which is the lowest part of Paynes Prairie, and that's a huge sinkhole that drains into the Floridan Aquifer. So it drained about 1,200 acres of Sweetwater or of Paynes Prairie, and so it effectively did provide that drainage that they were looking for. Well, as Gainesville developed in the 40s, 50s, and 60s, there was no treatment of stormwater. So stormwater that drained from downtown flowed into Sweetwater Branch, flowed to Paynes Prairie, and followed that canal to Alachua Sink and all the pollutants associated with it. And then halfway down, if you see the Main Street plant labeled, that's the wastewater treatment plant, also known as the Water Reclamation Facility. And that was built, and the discharge, like every other municipality, would be to discharge the wastewater into that creek, which flowed to Alachua Sink. So there was a huge pollution source of untreated stormwater and somewhat poorly treated wastewater going through down Sweetwater Branch to Alachua Sink into the Floridan Aquifer. So the city of Gainesville was required to come up with an alternative that would clean the water and prevent that pollution source from occurring. So these are the pollution sources, the advanced treated wastewater, the Main Street Water Reclamation Facility, that's where the wastewater is being generated from. And over the years, GRU has improved the quality of the wastewater, and it's now advanced treated wastewater. It's much higher quality than it was at the beginning when it was quite a pollution source. And then also the stormwater coming in. So the solution was a treatment wetland. And so that's when Sweetwater was born. And Sweetwater is a treatment wetland that is strategically located at the front end of Paynes Prairie so that it intercepts and captures the runoff from the wastewater, which is a consistent about 5.5 million gallons per day of wastewater, plus the stormwater that comes in through Sweetwater Branch. The water flows through the treatment wetland and then discharges onto Paynes Prairie in a sheet flow manner. When Sweetwater was constructed, that 2-mile-long canal that you can see is no longer there going to Alachua Sink, that was filled in. So now the water is sheet flowing out onto the prairie and actually hydrologically restoring that approximately 1,200 acres that was dehydrated from the canal. So a little bit about the performance of Sweetwater. It's primarily, it's designed to be a nitrogen removing wetland. the biggest pollutant coming in from the wastewater treatment plant is nitrogen. And so the water that's coming in has nitrogen in it. The total nitrogen, the average concentration is 5.72 milligrams per liter. That's the concentration of total nitrogen coming into Sweetwater. And as the water flows through Sweetwater, through the emergent cells, the nitrogen is removed through denitrification, and the outflow has less than 1 milligram per liter of nitrogen flowing out to Paynes Prairie. So that's a tremendous amount of nitrogen removal. Not only is it a lot of nitrogen removal, it's the hardest nitrogen to remove because it's at the lowest concentrations, that if that was performed at a wastewater treatment plant, it would be extremely expensive to accomplish. And so when they looked at a cost comparison of building a treatment wetland versus upgrading the water reclamation facility, you can see that the cost difference was almost twice as much to upgrade the water reclamation facility. And that's because it's very costly to remove the nitrogen down to those lower levels to remove that nitrogen. And plus that includes not only the upgrades, the construction upgrades at the water reclamation facility, but that would be the long-term operational costs of manpower and chemicals and upkeep of the facility. So economically, it was much more economical to build a treatment wetland. So the process for removing nitrogen, most people are under the assumption that the nitrogen is removed by the plants, from the plants uptaking the nitrogen and removing the nitrogen that way. And that's, the plants do uptake nitrogen, but that's not a net removal of nitrate or a net removal of nitrogen. The plants, when they uptake nitrogen, it's stored in their leaves and stems and roots, and it's kept within the system. And when they slough off the old biomass, when they're producing new leaves, that nitrogen gets put right back into the system in the sediment. So that's not the primary mechanism for nitrogen removal. The primary mechanism is denitrification. And denitrification, if you look on the right-hand side, the NO3, that NO3 is nitrate nitrogen. And you can see that it's nitrogen with oxygen attached. And so the mechanism behind this is a biological mechanism with the microbes, with the plants, and with anaerobic conditions. Anaerobic meaning that there's lack of oxygen, in this case, in the water column. So what happens is the form of nitrogen coming from the wastewater treatment plant is primarily nitrate nitrogen. It's the oxidized form of nitrogen. That nitrate nitrogen comes into the system, into the wetlands. The plants are constantly producing, dropping off old plant material as they produce new material, and that organic matter goes into the water column. And there's millions and millions and millions of bacteria and fungi and all sorts of microbes that are decomposing that organic matter. Well, since there's no or very little oxygen in the water column, those microbes, which are anaerobic microbes, are using the oxygen that's attached to the nitrogen as their oxygen source. And when they do that, they release nitrogen into the air, into the atmosphere. So that is the denitrification process. And that's how this whole system works, is growing vigorous plants that are constantly producing new biomass and dropping off old biomass. The microbes are in there decomposing that organic matter. They're using the oxygen that's attached to the nitrogen and the nitrate. And when they do that, they release the nitrogen gas in the atmosphere. Now, this process couldn't work if it was an upland system, like a spray field, for instance, because you have to have anaerobic conditions. Otherwise, you would not have denitrification occurring. So this is the schematic of Sweetwater Wetlands Park. Probably every one of you are familiar with it. I'm just going to mention a few parts of it. The brown areas are the berms that we walk around, just to get you oriented. So the water comes in at the very north end in that rectangular light blue area, and that's a sediment control basin and trash removal. that sediment basin is kind of a new design for treatment wetlands. Previously, treatment wetlands didn't have the sediment basin. And so sediment would come into the front end of the cells and require maintenance down the road to clean out the sediment. So that's a real improvement on the design of treatment wetlands. It's especially important for this project because Sweetwater Branch, the creek that flows into it, is very incised. It has high velocity storm flows coming in whenever there's big rain events, and there's a lot of erosion of sediments that occurs. So that was especially important to have the sediment basin at the front end. And of course, a lot of trash comes in too, so they can capture the trash more easily. The blue areas are the deep zones. There's an inflow deep zone at the front end, a middle deep zone, and an outfall deep zone at the south end. And there's the light blue colors that goes between cells 1 and 2, and on the north side of cells 2 and 3 are emergency overflow channels. And that is important for when there's really high flows coming in from stormwater. The stormwater, instead of sending all of that water through the cells, the water can bypass the cells and not flood out the cells. Because remember, you have to have vigorously growing, very healthy, vigorously growing plants for the denitrification process to occur. So if you had a huge flush of water coming in that flooded the cells 4 feet, for instance, you could have a decline in the plants. And so this is a way of protecting the vegetation and bypassing the cells with the large flush of water. The bottom blue area is the 1 mile long distribution channel. So water flows slowly through the wetland cells and reaches that bottom blue area and then discharges into Paynes Prairie and sheet flows. And that helps to distribute the water more evenly, having that long distribution channel. The middle deep zone is important because one of the important features of the treatment wetland is that water should flow throughout the entire wetland cell and not have short circuits through channelization, because you want water to have a huge surface area, maximum surface area throughout the entire wetland cell to maximize denitrification. So in the case of if flow channels develop at the front end of a cell, the deep water, the middle deep zone helps to catch the water, redistribute it so that you circumvent the flow channels from continuing through the rest of the wetland. So there's also water control structures at the beginning, at the front end, and at the north end and the south end of each one of the cells, and that directs the water into each cell and out of each cell. And so I'll show you those on this next slide. So on the right photo is one that you're used to seeing. This is the water control structure. And so if you, in the bottom left photo, you can see if you were to look down into it, there's an adjustable weir, and that adjustable weir sets the water level. And so if you raise it at the front end, then it's going to take a higher water level to come into the wetland system. If you raise it at the south end, it's going to hold water back into the cell. So that's how you adjust the water levels. They're pretty much not they're set at a certain elevation and pretty much left there unless there's any maintenance that needs to be done to lower the water level. So this is really a nice setup because in really high rain events where there's a lot of water coming in, the water levels are already set to protect the wetland cells, and water can just automatically bypass the cells, the extra water, and bypass the cells. And that's also really important for inclement weather. You don't want to have an operator going out during a tropical storm trying to set the water levels when there's really bad weather. So it's really nicely automated that way. And just to get an appreciation of these water control structures, that photo on the left was taken during construction. You can see the size of that control structure, and there's 2 workers behind it. So you can kind of judge the size based on those 2 workers. So GRU invested almost $2.5 million on the public use facilities. That was above and beyond the cost of constructing the wetland. And that money was raised through grants, a lot of grants through different agencies to get the public use facilities, which consist of the boardwalks, the overlook platforms, the parking lot, the restroom facilities, the welcome classroom. So a lot of very useful public use facilities. And these public use facilities have really paid off with number of visitors. You can see here a very high visitation, especially high in 2020 when COVID first hit, and Sweetwater stayed open when the other parks were closing, and people really appreciated that, and a lot more people visited Sweetwater during the pandemic. So a lot of visitation, a lot to see there. So I just want to mention a few things that Alachua Audubon has some of our contributions to Sweetwater Wetlands Park. We've been a stakeholder since the very beginning when it opened. In fact, they let us have bird walks before it even opened its gates to the public. But we have designed and this Let's Start Birding brochure. And if you open it, it has photos of 24 of the most common wetland birds at Sweetwater. It also has information on the birding hotspots around Alachua County. So, and it's a very, very popular brochure. We continually, every couple times a year, we're printing more copies and donating them to the park. We've teamed up with Visit Gainesville, and actually Visit Gainesville has been paying the printing costs for the last several printings of that. As Tim mentioned, we have guided bird walks every Wednesday at 8:30, going from September through May. And last year we donated 15 pairs of binoculars to Sweetwater Wetlands Park, so the rangers can use those whenever they have educational programs. We funded a whiteboard map, which just got installed last month, and that is very popular. It's a place that you can write in your observations on the map of notable observations, and other people, when they visit, they can see where certain wildlife were seen as shown on the map. One of the things that we're going to start this year is we will be funding the transportation of 4th graders for field trips to Sweetwater Wetlands Park and Morningside Nature Center. And it turns out that the rangers really want to have these educational programs for students, young students, but there's not the money for transportation. So that's where we're going to step in and kind of be a behind the scenes partner to fund the transportation for that. We're in the process of designing educational signs for cells 2 and 3, which are lacking educational signs. And then a project which we have our fingers crossed will happen is to implement a forested nature trail on the north side of Sweetwater. And this is a trail that was put in the original design of Sweetwater, but it was never built because that land is part of Paynes Prairie Preserve State Park, and it's taking, they have to change their unit management plan to recognize the trail before it can be built. So we're trying to keep that moving along, and hopefully this time next year we'll have a nature trail there. So why is Sweetwater so bird rich? If you look at eBird, the hotspots, it's actually number 30 on the 30th in the list of hotspots with the highest number of species, 259 species, which is phenomenal because it's only been open for 7 years. And then on the Christmas bird counts, we hover around 100 species on a half day of very intense birding just at that one site. So it is extremely bird rich. And the reasons for that are that it's very nutrient rich. There's a lot of nutrients coming in with the nitrogen, with the wastewater treatment plant coming in. And it makes for a very complex food web. Just a very complex food web that a lot of organisms are feeding on, and it just builds up in the food web. For us, it's manifested in a huge bird population. Water attracts birds. Wherever there's water bodies, there's going to be birds, especially when you mix that with nutrients. There's going to be a lot of birds. And surrounding Paynes Prairie, you have this wonderful, high quality ecosystem surrounding or on the south side of Sweetwater that contributes to the bird population. There's also habitat diversity there with the wetlands there's emergent marsh, there's shrubs, there's trees along the edge effect, and then the forested wetland or the forested uplands that's on the north side. All of that habitat diversity translates into more birds. And then not so much a factor of bird richness but the accessibility makes it so that birders can see these birds and tally them and record them on eBird. So that's probably the biggest reasons why Sweetwater is so bird rich. And of course, there's the additional benefits. It's not just that Sweetwater is cleaning the water and providing habitat, but it's also a wonderful amenity to the community. So that is one of the biggest reasons why GRU has decided to go forward with another treatment wetland. And so the new wetland, which we're all really excited about, is called the Groundwater Recharge Wetland. And that site, the location of the site is, if you can see the orange hatched line on the left, the project site, that is on Parker Road. Parker Road is 122nd Street. It runs from Newberry Road at the north end to Archer Road on the south end. And the site is 75 acres and it's located right next to Diamond Sports Park. And it would be on the west side of Parker Road. So, and this wetland, when it's built, will receive treated wastewater from GRU's Kanapaha Water Reclamation Facility. And that facility is located due east on Tower Road. I have it marked in red. It's right behind the sports complex and Chapman's Pond. So if you know where Chapman's Pond is, the Kanapaha Water Reclamation Facility is right behind it. So this wetland will be very different from Sweetwater. It will be smaller, 75 acres, and it's surrounded by uplands. It's not going to be, it's not very different from Sweetwater in the fact that it doesn't have Payne's Prairie there. So this is the Kanapaha Water Reclamation Facility that will be hydrating the wetland with about 3 million gallons of water every day. So the existing site, as it is now, is upland, very sandy, dry uplands. I believe the historic or the most recent land use was in some type of agriculture. The original vegetative community has definitely been disturbed. It's got an understory of a lot of dog fennel, scattered oaks and sweet gums, and very droughty, permeable soils. Alachua Audubon is again a project stakeholder in this project. We've been conducting quarterly baseline surveys for the last year. Adam Zions and Barbara Shea have been leading those bird surveys, and they've conducted 4, and so far they've documented 51 species. So we'll see a big change in the bird species once the wetland is built. This is just how GRU is visualizing, just kind of a visual of the site, although it's going to, who knows how it's going to turn out right now. This is just before the design has ever started, but it's going to have a combination of open water systems and trees and shrubs and certainly herbaceous species growing. It's going to have walking areas for visitors. It's going to have overlook areas for closer viewing of the wetland areas. So the wetland system is going to operate very, very differently from Sweetwater. Sweetwater is considered a flow-through wetland where water comes in at the north end, flows through the wetland system, and discharges on the south end. This groundwater recharge wetland is going to not be a flow-through wetland. It's going to be a recharge wetland where water flows into the wetland, the denitrification occurs, nitrogen is removed from the water, and then it infiltrates into the ground and recharges the groundwater aquifer. And so that's going to be a big difference from Sweetwater, is that it's going to be a groundwater recharge wetland. The design right now is for 3 million gallons per day of water coming from the water reclamation facility. And that will have, it'll be built with the ability to increase the capacity up to, I think, about 5 million gallons per day. So the schedule for it, this year was an important year for the project. The GRU purchased the property. They did their due diligence actually before they purchased the property by doing hydrogeologic surveys and other surveys to ensure that the site was suitable for a treatment wetland. They purchased the property and they have selected the design build team, which actually is some of the same players that designed and built Sweetwater. So that's really good. The design timeline is estimated to be 2 years, and construction would be 2 years. So that's a shorter timeline than Sweetwater, which took 3 years for design and 3 years for construction. So similar groundwater recharge wetlands that I just want to mention is one is that's nearby is the Ocala Wetland Recharge Park. And that is very conveniently located in Ocala, right off of I-75. It's open 7 days a week and it's free. And that wetland, that constructed wetland, receives wastewater from the Ocala Wastewater Treatment Facility. And it recharges into the groundwater, and it's lovely, and it has a nice boardwalk system that goes through 3 large wetland cells, and then there's a lot of educational signage there. So if you haven't been to Ocala Wetlands Recharge Park, I would highly recommend it. Another recharge wetland that I'm sure quite a few of you have seen is the Lake City Treatment Wetland. And this is not open to the public, but they have been very accommodating whenever we've asked to have field trips at the site or do the Christmas bird count. And so this site receives water from the Lake City Wastewater Treatment Plant. It's pumped to the lagoon at the north end of the site. And from there, the water is piped to the wetland, which is right below it. There's 9 cells, and the water flows to 3 cells. It flows into one, that one flows to a second cell, which flows to a third cell, and then it infiltrates into the ground and recharges the aquifer. And that's repeated for the next 3 cells and the next 3 cells. And that is interesting in that the location of the Lake City wetlands, the water in the aquifer is flowing south towards the Ecotourism Springs. And actually that groundwater is feeding the Ecotourism Springs. So this project was also approved because it's one mechanism for helping to protect and restore the Ecotourism. Oh, and I forgot to mention that there's a field trip. Alachua Audubon's having a field trip December 3rd to the Lake City wetlands. So if you would like to see that wetland, that would be a time to see it. So Alachua Audubon and Four Rivers Audubon have teamed together at the Lake City wetlands, and we installed purple martin gourds about 3 years ago because it was just the ideal place for purple martins. And sure enough, the martins agreed. They colonized the first set of gourds immediately. So each year we've added another set of martin gourds. Now we have 3 sets of 32 total gourds. In the last 2 years that we've monitored them, we've had over 100 purple martins that have fledged at the Lake City wetlands. So that's really been exciting to see all the martin activity and just the ideal place for them. And then I also wanted to mention that we have tallied a lot of birds at this site. 161 is noted on eBird, and that's pretty high, especially since this site is rarely birded, maybe a half dozen times every year. So very few birding outings, but lots of birds have been seen there. So just quickly on these last few slides, I'm going to just go through some of the construction sequence that occurred at Sweetwater so that you can kind of get a feel for what's going to happen at the groundwater recharge wetland. Well, for 3 years of construction was basically clearing the vegetation, and moving dirt, excavating dirt, moving it, and adding it in other places. And there was in the design, the plan was to balance the cut and fill at Sweetwater. And what that means is that whatever dirt was excavated, they used that on site to fill. And so they did not bring any dirt onto the site or take any dirt off of the site, because that's very, very expensive. So that was a real challenging engineering feat to balance this excavation and fill. But that's what occurred at Sweetwater, and I assume that that's how it's going to be at the groundwater recharge wetland as well. So once the clearing and excavation and fill was done, and the site was laid out, and it was by cell. The cell was an as-built survey was conducted to confirm that the wetland cells were built according to the design, especially the elevation. And so this shows you, this is cell 2. The open water in the front is the first deep well, the deep water zone. The dark area behind is the emergent marsh. And so that's with the elevation survey confirmed that the elevations were constructed correctly. And then it was planted. Once the earthwork is done, it's planted. The plants are harvested from a donor marsh, and they're transported in these plastic tubs. The plastic tubs have holes in them, so they're stored in the water so that they stay hydrated. And only the plants that are going to be planted for a day come to the site so that they do not dry out or get too stressed before they're planted. They're planted on 3 or 3.5 foot centers, and it took close to a month to plant each one of the wetland cells. Some of the there were 2 plant species that were planted along the shoreline: soft rush and sand cordgrass, with sand cordgrass showing the best survivability at the wetland. So those 2 were shoreline plants. The next 5 plants that I'll show you are the 5 that were planted in the emergent marsh: pickerel weed and lance leaf arrowhead, giant bulrush, and fire flag. And fire flag is a preferred food for purple gallinules. And we didn't know if there were going to be purple gallinules at Sweetwater. I mean, of course, they weren't there when it was first being built, but the fire flag is a preferred food. And this is the time of year where you can scan the fire flag and look for the gallinules. They climb up these seed stalks with their lightweight and very large feet and pluck the seed off of the seed stalk. And the 5th plant is jointed or knotted spike rush. And so this is a couple photos of the plants being installed, again at 3.5 foot spacings. That was for cells 2 and 3, and it was 3 foot spacings for cell 1. And this is what it looked like in cell 2, just 2 months after the plants were installed. This cell was planted in the spring, so when the plants were installed, they took off. I mean, they just grew like gangbusters, unlike cells 1 and 3, which were planted in the fall and then went into a dormant season. There were a lot of challenges with the plants. This is cell 1, and before the plants were installed, this Sesbania started popping up. It's a weed and just was covering the area. And of course, you can't plant small plants in this weedy area, so that had to be herbicided and removed before the plants could be installed. And then after the plants were installed in cell 2, cattails came in, and they grew almost before our very eyes. It just were growing like crazy. And that's because the soils, the substrate that was used here at Sweetwater had a huge seed bank of wetland plants. And so there were just the muck soils had so many seeds of wetland plants, and as we could see, especially cattails, and they just took off. So that was a real challenge to try to control the cattail when we just installed all these new plants. And then for cell 1, we installed the plants in the fall, and then the plants were just kind of humming along, not really growing because it was getting cool. And then all the coots arrived, and they thought they had a salad bar presented to them. So they started feeding on all these tender new plants. So that kind of took a toll on the plants as well. So there were a lot of challenges just from the, well, throughout the whole project, but those were some from the vegetation aspect. But this is cell 2 after planting, and as you can see, it really filled in. And if you look closely, you can see a lot of the plants that we had planted really coming through there. So the benefits, there's a lot of benefits to treatment wetlands. This is for Sweetwater, but it really, it's really a very environmentally sound way, economical, and just sustainable way of cleansing wastewater, cleansing stormwater, protecting the receiving water bodies. And then for Sweetwater in particular, it hydrologically restored a large area of Payne's Prairie that had been historically dredged and drained. And of course, it enhances wildlife habitat. You can, anytime you go out there, you can just see the abundance of wildlife. And for us users, it's provided a wonderful recreational and educational facility amenity for the community. So that's it. So if there's any questions, I can try to answer any questions.
Yeah, I have one question. There's southern wild rice, also called cut grass, is common out there, and that's a plant that a lot of the birds use. And you didn't mention planting that. Is that something that just came in from the seed source that was already there in the muck?
Probably some of it, Bob, came up from the seed source, the seed bank. But I remember in cell 1 in particular that there was very little wild rice. It was kind of on the south and southwest side. And then I could just see it slowly encroaching and moving in towards the boardwalk. And we talked about trying to control it somewhat because it was going to block the visibility from the boardwalk. But that probably was a combination of coming in from the seed bank, but maybe the seeds, if they're, I don't know how big the seeds are, if they're wind blown or if they're larger. And if they're larger, they would either have been dispersed by wildlife or in the seed bank.
Hi, Debbie. Thank you. Oh, sorry, go ahead.
So one thing though that is kind of similar to that, Bob, is in cell 2, there at the south end is a big tree island that has cypress trees in it. And the cypress trees have produced lots and lots of seeds. And we've noticed that they have germinated and they're lining the cell 2 wetland cell, especially on the south side. So when you walk there, those trees are really visible now. They're upwards of 4 to 6 feet high. And that's from those cypress trees were not planted. They've germinated from the trees that were produced from that tree island on the south end. Zach?
Yeah, I was just going to say thank you for that great presentation. And I figured I would volunteer to read some of the questions that were in the comment section for you.
Thank you. Okay.
All right. At the top, Eileen says, can we get a list of the 51 species seen so far? I think that's at the new site.
Yes. If the 51 species at the groundwater recharge wetland, yes, we have an Excel spreadsheet that has those. So if you, maybe the best way is if you go on the Alachua Audubon website and it's contact us and send an email requesting that, then I will see that email and I could send it to you.
Sweet. Tina says Ocala Wetlands has had problems with sinkholes. What is the anticipation? What is anticipated in regards to the new wetlands?
Yeah, sinkholes are a real concern. And actually sinkholes were concerned when Sweetwater Wetlands was being constructed too, because Paynes Prairie is a conglomeration of many, many sinkholes. And there's sinkholes all around the edge of Paynes Prairie. So when you're excavating an area, removing dirt, and then adding all the weight of water, if there's cavities under there, then you can have a collapse very easily. So any treatment wetland, there's a susceptibility of sinkholes. And so one of the maintenance or monitoring for Sweetwater is if it's ever detected that there's no water discharging at the south end of any one of those cells, but water's going in, then that's a good sign that a sinkhole could have opened up in Sweetwater. And if it's small, you may not see it, but if it's taking in the water and water's not discharging. So it's a concern. And she's absolutely right that Ocala had several sinkholes open up during construction. It's a very karst topography with a lot of cavities there. So that they had to fill those. That's a possibility for the groundwater recharge wetland, but one of the due diligence that GRU did was a very detailed hydrogeologic survey where I'm not sure the mechanism, but they did all sorts of tests to see if there were large cavities or voids present underneath the surface that could cause a sinkhole to occur.
Okay. Bill Cooper says, how deep is the Florida Aquifer on the upper boundary? I'm assuming that's the upper boundary of Paynes Prairie.
Oh gosh, I don't know. I mean, it varies. I don't know. In Gainesville, there's the Hawthorne Formation that's over the Floridan Aquifer. And then as you move out from the center of Gainesville, where it starts getting very sandy soils, you start losing the Hawthorne Formation, less clays in the soil, and you have much higher groundwater recharge. But it varies. I really don't know.
Right. Lauren says, is the wild rice what the bobolinks and buntings are eating?
Yes, that's one of the one of the food sources that they're eating. It produces a lot of seed. Which species? I know the bobolinks and indigo buntings. Is that what you said?
Yes.
Yeah. Mm-hmm.
All right. Tom says, why doesn't water percolate down at Sweetwater Wetlands?
Well, because there's a lot of clay in the soils, and it's very clayey. It's not permeable soils. It's a wetland system. There's mucky soils, and so it's just it doesn't have the substrate. And then also you have the water table is close to the water table there, so you don't have a dry area for water to drain into. So for all those reasons.
Alrighty. Eileen says, I live on Parker Road. Are there volunteer opportunities?
There certainly could be. When it gets built, yes, we would probably love to have volunteers for all sorts of things. So yes, I'm sure there would be.
Right. Tom says, do we know the organisms involved in the denitrification process?
Oh gosh. Well, they're called denitrifying bacteria, anaerobic denitrifying bacteria. And that's about as much, Tom, as I can tell you. But they're specialized for anaerobic conditions, and there's a whole host of different organisms. They're also native. They were not added to the wetland. They are just there naturally. They're throughout every water body, unless there's been some kind of toxic spill or something. They're throughout Paynes Prairie. So they're just, the whole system was inoculated as it was being constructed.
Right. Ann Wiley says, the new site in Upland has lots of nice live oaks. Since I live in Fort Lauderdale, every live oak we try to save. Will there be an effort to keep some of these great native trees and plants?
And probably so. I would imagine that they'll do a tree survey and identify all the large trees. That's what we did at Sweetwater, actually. And that's why there's some tree islands that were left in cell 2, because there were trees that we wanted to preserve. So I imagine that they will, to the best of their ability, because the having large trees will add tremendously to the whole system in terms of appearances and habitat.
All right. Tootie says, just made a comment about invasive plant issues. If you're still on, did you have a question, Tootie?
No, I was just wondering if there's a plan to deal with invasive plant issues at Sweetwater and the new place.
So, yeah, I can address that. Sweetwater, the cells, gosh, they were like, I don't know, 40 acres in size or so. And so it was not feasible once the plants, the desirable wetland plants were installed. It was not feasible economically or from a safety standpoint or a logistics standpoint to go in and try to remove invasive plants and just select for the plants that we had identified and installed. So it was, the approach was to install the desirable plants, and then whatever happens is going to happen. Whatever grows is going to grow out there, because it just was not feasible to do any kind of control. The purpose of the wetland, as I mentioned earlier, is a nitrogen removal wetland, and it really does not matter what kind of plants, to a certain degree, are growing, as long as you have vigorously growing plants that are covering the whole wetland and producing organic matter to feed the microbes. You're going to have a high amount of denitrification occurring. So if it's all cattails, you're still going to have good denitrification. But we were trying to set it up so that we had native wetland plants, although cattails are native, growing out there, so it was more aesthetically pleasing. And but once the plants get going, it's just too big of a project to try to control invasive or exotic species.
All righty, that is all of the questions and comments in the chat.
Thank you, Zach. That helped a lot.
No problem.
All right. As far as parting shots, reminder about our field trips coming up. Not just this weekend, but throughout the fall and into the winter. Our Wednesday wetland walks. Zach, what's the next program on?
The next program will be Jonathan Barrell presenting on the banding lab here at the Prairie Creek Banding Station. Just an overview of the banding efforts and their ongoing successes.
Awesome. Oh, last weekend we had 25 different birds. That was our first weekend at the of the season at the Prairie Creek Banding Lab. And we caught our first ever worm-eating warbler. So make sure y'all, this is a presentation y'all won't want to miss. Jonathan is very charismatic as well. So, very engaging as far as a speaker. So I'm definitely looking forward to that. And, good way to find out what birds we have moving through. And y'all are really going to want to hear about what the future holds for the banding lab as far as the MODIS system and different types of like radio tagging and things like that. So thank you Zach, for looking forward to that. And that'll be the first one that you'll be moderating. So it'll be great. Y'all don't want to miss it.
And Tim, I have one more comment to make. Felicia just reminded me to mention this is so I have a publication coming out in American Birding Association's Birding Magazine in December about treatment wetlands, and it starts out with Sweetwater wetlands and then pans out to treatment wetlands in general and the benefit. And so that will be coming out this December in ABA's Birding Magazine.
Nice. Yeah, that's going to be awesome. congratulations too, again. Oh, also, before I forget, it's still a few months away, December, but if y'all haven't started thinking about it yet, make sure that you email Andy Crider or Bob Carroll to let them know that you're interested in being on the this year.